So if we take a look, function notation is read f of x or f at x, not times, is not times. Most of the time in class I'll probably say that one. Sometimes if you're reading graphs that one might help. But this is function notation, f parentheses x inside of it, meaning f of x or f at x. Okay? So if we take a look, this kind of lays out how this function is represented. So your input is your x, your independent variable is always your input, which is always your x coordinate. Your output is your y, it's telling you the result. What happens when x is this? What's the new result? Your equation is your standard equation with x and y in it, but instead of y, we now have f of x. So we read this equation as f of x equals $3 or 3.50h plus 4.75. So we need to find f of 30. This means evaluate the function by substituting 30 in for x. So what they're asking you to do is how much money are you taking home when you work 30 hours? That's what we need to figure out. So you start the function with f of 30 equals, and now we just substitute that value in, 3.50 times 30 plus your initial $4.75. So after you do that, working 30 hours will bring you $109.75 as your take-home money. So now what we're going to do is we're going to just practice evaluating functions for each of these values. So f of 4 for f of x is equal to 2x plus 3. So you have f of 4 is equal to 2 times 4 plus 3. Well, 8 plus 3 is 11, so f of 4. So when f is at 4, the result is 11. So now we're going to do the same for h of negative 5 is equal to negative 5 cubed minus 2 times negative 5 squared plus 5. Again, be very, very careful with using your calculator here. If you get this wrong, it's because you didn't plug it in your calculator right. Have to use parentheses when substituting in a negative value. A negative number. I'll rewrite that in case you guys can't read what that says. That should say negative. A negative number, especially when you're squaring it or cubing it. So if you type it into your calculator exactly as I have it on the board, we find out that f of negative 5 is actually equal to negative 170. So if you take a look, part C, we have g of negative 2 is equal to 2 times negative 2 squared minus 1. So negative 2 squared, remember, is always a positive. Don't let your calculator fool you. So 4 times 2 is 8 minus 1 is 7. So g of negative 2 is positive 7. So g at negative 2 is 7. Now if we plug in a binomial, because we've seen these before in our last unit, you just literally substitute in that entire binomial as is, and then you just have to distribute. So f of a plus h is equal to fa plus 5a plus 5h plus 7. You can't combine anything, so that's your final result. And those are a couple examples on how to evaluate. Remember, the name of the game is substitution. Double check how you plug in negatives, especially into your calculator using parentheses. And then the last topic we're going to talk about is functions and tables. So function f is defined by the table that's given to you in your notes. And it says explain why the table defines a function. Well, this goes back to how do you know if it's a function? Because for every one domain, there is exactly one range, or only one range. So find the domain and range. So all we need to do is list our x's, -2, -1, 0, 1, and 2, and our range, same thing, 5, 0, 3, 1, and 4. And then it says find the indicated function values. So what this is saying is find f at -1. So they want you to tell us the y coordinate. So this is saying find y. So find -1 is x, here it is, and then it's associate the y coordinate is 0. So number 2, same thing, it's telling you find f at 0. So that means find find y when x is equal to 0. X is 0 here, so that means the y value is 3. This one even tells you in words, find x, such that f of x is equal to 4. F of x really stands for y. It's saying find when y is 4, what is x? So the answer to that is x is 2 when y is 4. Now we're going to practice obtaining information from graphs. So I'll read this because I know it's probably a little bit small on your notes, but you have this a little bit larger on the video so you can read it. The human immunodeficiency virus, or HIV, infects and kills helper T cells. Because T cells stimulate the immune system to produce antibodies, their destruction disables the body's defenses against other pathogens. By counting the number of T cells that remain active in the body, the progression of HIV can be monitored. The fewer helper T cells, then the more advanced the disease. So figure 8.8 shows a graph that is used to monitor the average progression of the disease. The number of T cells, f of x, is a function of time after infection, which is x. So we're thinking time, well, that's your independent variable because time is going to determine how many T cells you have left, which is why the T cell count is your dependent variable on the y-axis. Oops. So if we go back, it says explain why f represents the graph of a function. So if you take a look, you can draw a vertical line anywhere and you can see that nowhere will x repeat. So this is a function because for every one domain there is one range. There's only one range. Use the graph to find f of 8. So f of 8, that says when x is 8, what is f of x? So we take a look on your graph of f of 8, go to x, go to 8, and then read it over to your f of x part, and that is 200 T cells. You have 200 T cells. So for what value of x is f of x? 350. So this is telling you find x. Make sure you guys read the directions if you're not sure which one you're solving for. This one says find x when f of x, so this means y, when y equals 350. So find 350, here it is, and then you just look across, oops, down here, sorry. So here's about 300. So 350 is probably about right here-ish. So you look across and you find where is 350. That will be about right here when x is 6 years. Is the T cell count at 350. And then it says describe the general trend by the graph. So if we take a look at the graph, you have to be able to analyze it and describe it in words to someone. So you can tell that initial on in the years, at 0 years, you have a very high T cell count. But then as years go on, your T cell count becomes less and less and less. Okay? So as time increases, as time goes on, as time increases, the T cell count decreases. So let's think about that. What